Is there a previously unknown planet hidden in the farthest reaches of the solar system? More and more astronomers now assume that the mysterious Planet 9 is real. And mind you, this is not a vague guess but a solid conclusion. After all, the strange anomalies in the Kuiper Belt literally scream that a huge celestial body is hiding here. But that's not all. A team of researchers is now even sure that an undiscovered planet must lurk at the edge of our home system. But what led the experts to this sensational assumption? Why has Planet 9 still not been officially confirmed? And why is it so complicated to track it down? Have you ever wondered where the comets actually come from? Well, if so, then you have something in common with the Dutch astronomer Jan Hendrik Oort. Since he was not satisfied with the fact that the source of the comets is somewhere out there, he postulated a bowl-shaped zone at the edge of the solar system in 1950, which acts as a natural reservoir for the comet cores. Unfortunately, the so-called Oort cloud was only able to explain the orbits of long-period comets. But a certain Gerard Kuiper came onto the scene the following year to explain the background of their short-period counterparts. And although the Kuiper Belt is now firmly established as part of the basics of astronomy, it would take another 40 years before its actual existence was officially confirmed. In detail, we are dealing here with a ring-shaped structure of icy debris that extends just outside the orbits of Neptune and Pluto, and which, in addition to comets, also contains frosty chunks and small planets. But beyond that, and this is the exciting part, the Kuiper Belt has been suspected for some time now of literally hiding something bigger, a giant planet that has successfully eluded our earthly research to date. But what is this exciting assumption actually based on? And how realistic is it that we have simply overlooked a full-grown planet for generations? Well, not that unrealistic. As mentioned, the planetary secret would be hidden far beyond the orbits of Neptune and Pluto, and thus so far away from us that it would appear invisible even to the most powerful telescopes of our time. Fortunately, however, direct observation is not the only tool at the disposal of experts in their search for a planet. And if there is anyone who knows how to crack the riddle of the Kuiper Belt, it is Michael Brown. The American astronomer has been dedicating himself to uncovering the icy worlds at the edge of our home system for quite some time now. He named the largest of these worlds Eris, but he could have just as easily called it Pluto Killer. In fact, the discovery of the dwarf planet contributed significantly to Pluto being removed from the list of official planets in 2006. And while the planetary banishment still causes outrage in some circles to this day, Brown continues to look back on his decisive find with a mixture of humor and pride because on X, he actually calls himself Pluto Killer. On the trail of Planet 9, 2006 was not only the year of Pluto's farewell, but also the year in which the discovery of the so-called distant detached objects set a much larger astronomical ball rolling. The objects, also discovered by Brown, actually formed the cornerstone of a research study that led to a revolutionary result. Yes, a completely unknown planet could really be hiding in the remote world of the Kuiper Belt. In detail, the self-proclaimed Pluto Killer, together with his colleague Konstantin Batygin, investigated the question of what the strange orbits of those mysterious objects are all about. In fact, follow-up studies had shown that 6 of them describe an elliptical orbit that points in the same direction. This seemed all the more confusing given that the objects actually migrate at different speeds and their orbits are not the same size. But the common orbital inclinations seem no less puzzling. After all, the orbits of all 6 celestial bodies deviate by about 30 degrees from the orbital plane of the other planets and objects in the solar system. So, can it really be just an unusual coincidence? Well, Brown answered this question with a definite no right from the start. He even estimated the corresponding probability at just 0.7%, making the idea of coincidence seem out of the question. And yet, it was not initially the ominous Planet 9 that was held responsible for the anomalies in the Kuiper Belt. At first, astronomers suggested that the gravitational effect of several massive objects, such as a group of dwarf planets, was responsible for this. Ultimately, however, this theory had to be discarded just as quickly as it had emerged. After all, for such a scenario, the Kuiper Belt would have to be 100 times more massive than it actually is. Consequently, the mystery had to be solved from a different direction. A few simulations later, Brown and Badigian came to the remarkable conclusion that all the observed anomalies could be explained by the existence of a planet about the size of Neptune. To account for the data, its orbit would have to be shifted 180 degrees from that of the remaining planets and Kuiper Belt objects. And indeed, the astronomer duo realized, in the period that followed, that more and more observations coincided with the presence of such a planet. Among other things, this could explain the special orbits of the trans-Neptunian object Sedna and another large celestial body without any gaps. But does that really settle the matter? Why haven't we discovered Planet 9 yet? According to expert models, Planet 9 weighs between 9 and 10 Earth masses and orbits the Sun at a distance of 400 to 1,500 astronomical units. To put this in perspective, 1 astronomical unit corresponds to the mean distance between the Sun and Earth, around 150 million kilometers. While our earthly home takes 365 days to orbit the Sun, Planet 9 would take about 20,000 years, assuming that it really exists. This mysterious planet is, therefore, out of reach of our normal telescopes most of the time. Moreover, Planet 9 is most likely very faint. Model calculations from a team at the University of Bern have shown that its intrinsic luminosity is only 0.06. For comparison, Neptune has a value of 0.01. Furthermore, the feeble radiation of Planet 9 could also be mainly in the infrared range. This means its temperature would hover around 47 Kelvin, minus 226 degrees Celsius, making it only slightly warmer than its cosmic surroundings. But do all these factors mean that we will never be able to confirm the existence of Planet 9 beyond doubt? Well, not necessarily. If the celestial body is currently closest to its closest point to the Sun, it may have already appeared undetected in the images of past sky surveys. Even if Planet 9 is currently far from the Sun, hope is not completely lost. With the help of advanced telescopes, such as the Vera-C-Rubin Observatory, which is expected to come online in March 2025, astronomers could locate this elusive planet. However, the confirmation of Planet 9's existence would not only expand our understanding of the solar system, but also introduce new cosmic mysteries. Why? Because its existence challenges fundamental theories about planetary formation. According to conventional understanding, large planets form in regions where the primordial gas and dust cloud provide sufficient material for growth. Planet 9, however, appears to defy this principle. Its average distance of around 700 astronomical units places it far outside the zone where enough material would have been available for such a massive planet to form. This brings us to a crucial question. How could a planet only slightly smaller than Neptune end up in such a remote and eccentric orbit? Theories surrounding its formation have pushed current models of planetary formation to their limits. One possibility is that Planet 9 formed in its current location, but this is unlikely given the lack of sufficient material in such a distant region. A second theory proposes that the planet formed closer to the Sun, alongside Jupiter, Saturn, Uranus, and Neptune, and was later ejected into its current orbit due to gravitational interactions. However, this raises another question. Why didn't it get completely ejected from the solar system? A third theory suggests that Planet 9 might not have originated in our solar system at all. Instead, it could have been a rogue planet captured by the Sun's gravity as it drifted through interstellar space. This possibility is intriguing, but statistically unlikely. Despite these challenges, researchers remain optimistic. Observational advancements and ongoing theoretical studies might soon provide concrete evidence for Planet 9. Moreover, the James Webb Space Telescope and other upcoming observatories may play a critical role in detecting the planet or its effects on surrounding objects. The search for Planet 9 is more than just an effort to find a missing piece of the solar system puzzle. It represents humanity's drive to uncover the unknown and redefine our understanding of the universe.